Okay, so hello everyone. This is the most important topic of the whole course. From here, you'll see uh, practical examples also. So in the previous video, I've explained you how to install the ISCE2 and what is an interferogram. Today, we are going to see how ISCE2 transfer two sentinel images into an interferogram. That means we are going into the actual work process. So to make this easy to understand, I will demonstrate you one complete processing workflow step by step. See, for the real-time processing, take lot of time. So what I did is I just downloaded two images and then I'm running them step by step. So here, what we are doing is we are going for the Ubuntu and then just like you all know about this Ubuntu and then wait for the terminal to run. And we know we have to activate the MintPy. See, if that is the case, then you can just put type up Honda activate MintPy. Then you have the MintPy environment activated. Now, first thing is I wanted to do every step individually, but because the videos are short, so I'm just using a single script for the demo. So you can really have the feel of how the real processing is going on. Okay, so the first step is we are just taking the two images and I'm letting the ISCE2 to read those Sentinel data. So this is a demo simulator which I'm running right now. So if I go for the enter, now the step is both the Sentinel-1 and Sentinel-2 are uh, read it and you got the orbit files and you also needed them and then we have to co-register the master and slave. Then we need to estimate the time of image offset and then resample the second image and then generate the interferogram and removing the topographic phase. See, this step which you are seeing right now is like the data which you are processing in other softwares, Snap or anything. It will take a lot of time. So you can better go for a script or you can let the ISE software understand where your um, data is. It will automatically read the data. So you see here, the first step, reading Sentinel-1 and Sentinel-1 scene 2. So if you have more number of data sets and if you let ISE to access your location, it will automatically start reading all the SLC scenes. Say example, if I have 500 images, all the 500 scenes are read and then it will automatically download the required orbit files and then it will start processing the orbits. So here what will happen? Every Sentinel-1 image is generally accompanied by an orbit information. So ISCE2 will check whether that precise orbit is available or missing. If the orbit is missing, then it will start downloading that orbit. These orbit files will improve the geometric accuracy of the final product. So if there are no orbits, then you cannot get the proper interferogram. So there are two ways to download this one. When you are downloading the Sentinel image in Copernicus or other places, you also try to download the additional information which contains the orbit files. So along with your Sentinel imagery, you also get the orbit files. Or it will be like if you don't download, later also it will the software will prompt you to say that this is missing. So either we have to download at that time or we'll have to run one more script which downloads the orbit files. Okay, that is for the third step. And coming to the fourth step, this is very important. Here, what will happen? We need to load a DEM. Right now, I have a Copernicus DEM, which is global, 30-meter resolution. So I have downloaded that. If you are using any other DEM, you can just use that. Generally, we go for the SRTM DEM. So this digital elevation model will help in removing any kind of topographic contribution from the radar phase. Okay. So here what will happen when you are loading the DEM, it will make your processing easier. Okay. And in the next phase, we are co-registering the images. Like I have explained you earlier, we create the first image as master and the second image as slave. So these two images are getting co-registered. So this is one of the most important step. So two sentinel images, they are aligned with high precision. Even a small misalignment of or a fraction of a pixel can degrade the interferogram. So this alignment process, which is called as correlation, is very important. So you have to be very careful and please check if there are any errors. And you can also let me know in the comment so I can explain you it clearly how to go about the correlation process. And in the coming videos, I can also show you some real-time data processing, but it will be a very lengthy video. If you are okay, then I can manage with that one also. And then we are going for the next step of six, that is estimating the image offset. Here, ISE is now calculating the geometric difference between the two images. That means the first image and the second image. That means the master and the slave. These offsets help in improving the image alignment before the interferogram formation. So this is also very important step. And after that, we are going for the resampling the secondary image. This secondary image is resampled because if you don't do it, then the pixels corresponding to the master will not match. So you need to resample the second image with respect to the master image. Only after this step, the two images can be compared pixel by pixel. So this is very important because most of the time when you are going for the snap software, you can directly go for the build graph and then you have to select the values and then you will be doing the processing. But you cannot do hundreds of images at a time. So we are using this ISCE2 and other processing. Now, the most important thing is generating an interferogram. Here, what will happen? This is the most important part because ISCE2 compares the phase difference of two radar images and then it creates an interferogram. So I can show you one, like I showed you in the previous video about an interferogram. So the colored fringes represent the phase difference. So these phase difference may result from the ground deformation and topography and depends on the atmospheric delay and also noise. So at this stage, we cannot determine like which effect is responsible, but we have created the interferogram. After that, you need to go for the removing of topographic phase. This you see, like Earth terrain will also contribute to the radar phase. So when the it's going like this, so because of the curvature, you might have some differences, right? So using the DEM and ISCE2 will estimate and it will remove most of the topographic contribution, like I've explained in the previous step 7. So these phase differences may result from topography also. So in that eighth step or the ninth step, removing topographic phase, this ISCE2 will estimate and remove much of the topographic contribution. And in the next step, we are going for the estimation of coherence. So coherence is image. I'll just show you the coherence image now. So here you are looking at a coherence image. Okay. Along with the interferogram, ISCE2 will generate and calculate the coherence. Coherence will tell you how reliable the interferometric measurements are. If you see here and here, there is a lot of difference between them. So I'll explain you clearly about what is coherence and everything in detail in the next video. So this is how coherence looks like. Now we are here at the next step, geocoding the products. So here geocoding is something, the radar coordinates are different from the geographic coordinates. Now ISCE2 will convert these products into geographic spaces so that they can be displayed correctly on maps. And like if you are plotting it on Google Earth or if you are using any GIS software, The conversion will help you in exactly placing those products on that software. And finally, writing out the files. Here, these data sets, they are completely processed and they are exported to the destination. So the processing is completed here. You have the Sentinel project, orbit, merge. Now I'll show you the path also. So here you can see the coherence image. So what is it telling? Along with the interferogram, the ISCE2 will create and calculate the coherence. Coherence will tell us how reliable the interferometric measurements are. So we will discuss about this coherence in detail in the next videos. Now I'm going to the next step. So here estimating coherence is done. Now we are going for the geocoding of the products. Now geocoding means radar coordinates are different from the geographic coordinates. So when you directly open the radar coordinates in Google Earth or some other platforms, they are somewhere outside or out of your place. So what IACE2 will do is it will convert the products into the geographic uh, space so that they can be displayed correctly on the Google Earth or any kind of GIS software you are using. So you can understand like this image belongs to this place. And in the last step, we are going for the writing output files. That means whatever the data we have made, that is all saved into this particular location. Or you can see it's like saving. So all the data are saved. So this is how the general workflow will be. And these outputs are used as inputs for MinPy. So in this video, we have successfully generated the interferograms. And in the next video, we will learn how to evaluate the interferogram by using the coherence and also understand why some interferograms are much more reliable than the others, because every time when you create an interferogram, because of some changes there will be a difference. So you need to understand like why some interferograms are more reliable than the others. So please do watch the other videos and please do comment if you have any queries. Then I'll reply you in the comments, and please do subscribe for Geoscience Engineering. Thank you.